All right. Okay, so, am I good? Am I on screen there?
Yeah, right now you are.
All of that?
Yeah.
Okay, all right. So, this is for period 6 people as well. So, significant figures. What is a significant figure? Well, you will have this sheet shortly. A significant figure is how many digits or numbers in a number are significant, or what numbers actually count and what numbers don't count. Now, this might sound confusing. I'll give you a real quick example. If I have 2 scales in the back, okay, so just pay attention, don't write anything down. So if I have 2 scales in the back, and I put a beaker on top of an empty beaker on top of the scale, and scale number 1 tells me the beaker has a mass of 189.45 grams. Okay, that's what beaker number 1 says. And then scale number 2, the same beaker. So I take the exact same beaker, I take it off scale 1, put it on scale 2. It gives me 189.5 grams. Which one, I haven't really taught a whole lot, but just use the word, try and think about the word and what it means. Which number is more significant? Which measurement, don't say it out loud, raise your hands. Which number is more significant? Which one's a more significant measurement? And this is what significant figures are all about. Page. Number 1 is more significant. Very good. This is more significant. It's a more significant measurement because it gives us more data, more information. Very good. Yes, this number here has 5 significant figures. Every single number there is called a significant figure. This one has 4 significant figures. What's the difference between these 2 numbers, Aiden?
One's rounded up.
Yeah. What's that decimal place called?
Tenth.
Tenths. What's that?
Hundredth.
Hundredths. So the more decimal places usually means more significant the measurement. Does that make sense? If you were to get on a scale and it only gave you, I'm trying to work backwards now, the hundreds place. Okay, so if we all stepped on a scale, we would all weigh 100 pounds. If it wasn't more significant than 100, that doesn't make any sense. Okay, there's tens and then there's the ones place. So measurements with more decimal places are more significant. If the scale only told me 189, that's even less significant than these, right? So more decimal places usually means more significant. Does that make some sense? Steve, you with me?
Yep.
Okay. Now, it's easier for you guys to see than period 6, but they will be sitting here and Miss Rogers can help out with that. So here's a graduated cylinder. Here's a beaker. Which one do we use for measuring volume? Jake?
The cylinder.
Why?
Because it's more accurate.
Good. Give me another word we're learning today. It's more significant, right? There are, so if I go to 10 and then between 10 and 20, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 graduation marks. So each one, if this is 10 milliliters and that's 20, I know it's hard for everybody to see, but if it's 10 and 20 and then there's 9 lines between, each line is how many milliliters?
1.
1, right, 1 milliliter. Okay, so that'd be 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, if I was to try and use this beaker to measure volume, it doesn't even have a 10 label. It has a line and then there's a 20. So in other words, the graduated cylinder has 10 and then 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 20. That's the graduated cylinder. Is this still on the screen?
Yeah.
Okay. This beaker here has a line and it goes up like this, and then there's 20. So here's the beaker. That's not even labeled 10. So you'd have to estimate and say, all right, I guess that's 10. And then are there any graduation marks here?
No.
No. So if you have the meniscus here, I don't know, what is that? 12, 11.2, 11.5, 11, I don't know, 13. It kind of depends on how you feel or how you read it, right? Whereas the graduated cylinder, it's more a little bit more accurate, a little more specific. So if it's right there, that's 11, 12, 13, 14, 15. It's between 14 and 15. We still have to estimate. Maybe that's 14.3. All right, you're still estimating, but you have a better chance of getting a significant reading here, a more significant number than this. This is just straight up guessing. So that's where significant figures come from. So that's the term, and that's why I'm talking about it. That you need to understand a tape measure is way more significant of a measurement for measuring this room than a meter stick. Same concept. So the beaker and the meter stick, there's more guessing. The measuring tape and the graduated cylinder, there's more graduation marked. It's longer, so it would work better. So that's where significant figures come from. All right, as far as the terms, why does it exist? Why are we learning it? So you understand some things are more meaningful. Accurate's a good word, but significant figures is how we word it. All right. So hopefully that makes some sense as to why we're doing it. A lot of times in the past, I would just teach this. I would say, all right, we're learning about significant figures. Never explain how it's relevant to anything. I would just teach the rules. The kids would learn it, but I think that's empty, right? So if you now understand why we're doing it and how it's useful in real life, I mean, it's important to understand why you would use this to measure something, not a piece of string, right? You're not gonna take a string and then measure this room with string, 300 times, and then measure the string and then multiply. Like, that's crazy. Just use a tape measure, right? You wouldn't use a piece of string. So you already know that, but it's because of this, more significant measurements. All right. So hopefully that makes a little sense to you, or a lot of sense. So now, what you need to be able to do coming into class on Monday is look at a bunch of numbers on a piece of paper. I'm going to give this to you in a little bit, and you're going to tell me how many significant figures are in that number. So if you look at the sheet I just gave you, it kind of explains it. I'm going to explain it right now and teach a little bit more before I let you work, but I use the Pacific Atlantic method. I learned it from Mr. McConnelly. I can't take credit for it. But the way he teaches it is you look at a number and treat it like it's the country. Okay? The good old US of A. So let's pick a random number like 834.05 centimeters. Okay, let's write this down somewhere on that sheet. Write this down somewhere on that sheet. Okay. So here's how we do it. What do you call that thing? Decimal point. It's in the number, so I say it's present. Okay, now what does that do with the Pacific and Atlantic? So let's look at this, and let's say this is the country, okay? Here's the East Coast, here's the West Coast. So this could be New York, this could be California. Where's the Atlantic Ocean? Right. Atlantic, write that down. There's the Atlantic Ocean. Where's the Pacific Ocean? Off the West Coast. Okay. Here's the rule. Here's how we do it. And it's very simple, so really pay attention. The first time, bless you, the first time you hear something usually is kind of the most important, right? So we don't have any misconceptions. If the decimal point is present, that means Pacific. They both start with a P. Really, that means present. So, if there's a decimal point present in the number, we move to the Pacific side of the number. So we come over on this side of the number. Now what we do is we start counting our significant figures with the first non-zero number. So we start counting from this direction because the decimal point's present, so we go to the Pacific side. And that's what the notes on the sheet say, okay, but it's just going to take practice before you get good at it. So again, it's present, we go over here. So now we start counting numbers with the first non-zero number. Is that a non-zero? Yes. Now here's the, after you understand that, the only other thing you need to remember is once you start counting, you don't stop counting until you run out of numbers to count. So, we go 1, 2, 3, 4, 5. 5 sig figs are in that number. Why? Because there's a decimal point present, we go to the Pacific side, we start counting from the left or the west coast, however you want to understand that. Start with the first non-zero, 1, 2, 3, 4, 5. That has 5 sig figs. Let me give you another number. 0.062 centimeters. 0.062 centimeters. Is there a decimal point present? I'm still on screen there, right?
Yeah.
Okay. There is a decimal point present. We go to the Pacific side because there's a decimal point. We start counting from the left because that's where we go. We go to the present, the Pacific. You start counting with your first non-zero. Is that a 0? Yep. Is that a 0? Yep. So we do not count those. We start with the 6. 1, 2. 2 sig figs. I'm going to give you one more example with the decimal point present, then we're going to do numbers without a decimal point. Okay? What if we had 0.00820 centimeters? Write that number down. And yeah, this is a really obscure, super tiny number, but decimal point present. We go to the Pacific side, start counting from the left. Start with the first non-zero number, and then the last part of the rule, you keep counting until you run out of numbers. Is 0 a number? Yes. This is the part some students get confused. You cannot start with a 0, so you don't count those. You start here, but you do count that. 1, 2, 3, because it is a number. Once you start counting, you count them all, even if it is a 0. You just can't start with a 0. So this has 3 sig figs. 3 sig figs. And this is why I'm going to have you do the worksheet. You might make mistakes, but you'll practice and get better at it. Okay, that's with present. Now, what if we have a number without the decimal? So let's go with 707, we'll go 7,750 meters. 7,750 meters. So, decimal point is absent. That means you go to the Atlantic. The A is for absent. So now if the decimal point is absent, we go to the Atlantic side. We start counting from the right. That's a bad arrow, sorry. Start counting from the right. Same rules apply. You cannot start with a 0. Once you start counting, don't stop until you run out of numbers. So we start with our first non-zero. We skip that 0. 1, 2, 3. 3 sig figs. What? Sif figs? I keep doing that. That's bizarre. It's because I'm thinking the F while I'm writing the sig. Anyways. So 3 sig figs. Let's try another one. What if we have 909 milliliters? Decimal point is absent. Start on the right, because that's where the A is, the Atlantic side. You go to the Atlantic side, absent side, whatever is going to make sense to you. Is the 9 a non-zero? Yes, so you start with that 9. 1, 2, 3. 3 sig figs. One more example. And if I'm betting, period 6 might be out of time because it's a shorter period. So we'll see if you have time or not. One more. 10 liters. I try to use units so numbers aren't just made up. Not completely. How many sig figs?
1.
1. Start on the right. Why? Decimal is absent. You can't count zeros, not in the beginning, not when you start counting. Don't start there. You only have one number, one sig fig. I almost did it again. One sig fig. Sig fig. You would think it's a Monday. I'm all discombobulated. So, right now, till the end of the period, I want you to work on the sheet I didn't give you yet. It's right here. All you're doing is this. You're telling me how many sig figs are in the number. We'll talk about scientific notation next week. So, period 6 as well, you're working on this. This is due Monday. This is due Monday for you guys too.
We get one more.
One more.
Never mind.
Oh, I'm still recording. Have a good weekend.